Hi everyone, welcome back to another honors geometry video. So for those of you who don't know me, I'm Ms. Warren, one of the honors geometry teachers. And in this video, I'm basically just going to walk you guys through some examples of translations and reflections for a review now that we've pretty much finished those topics in class. So the objective we're going over is that given a point, shape, or line, I will demonstrate my understanding of translations and reflections both on and off a coordinate grid. So once again, we are going over both translations and reflections. This is an objective you may have already met. We have, again, had a class and videos for each of these topics individually, but we're just sort of going over this review to make sure that you have indeed mastered this objective. Okay, so as I start going through this, I'm going to just go through two examples of translations, and then we're going to move on to reflections afterwards. So this first question here on the left is a preimage of a triangle, and we're going to go ahead and translate that triangle. So they've already given us our coordinate notation. So the first step is to write the verbal description of this notation. Okay, so the coordinate notation has xy becoming x minus 4 and y plus 3. So as you guys hopefully remember, when you add or subtract a number to the x value, that moves you left or right because you're affecting the x coordinate, which the x-axis moves left to right. So because we are subtracting 4 from x, that means that we are translating my pen is not working great. Sorry about that. Translation. Oh, huh. This is interesting. Sorry. Nope. I usually don't have this problem. I don't know if that's going to do anything, but we'll try. Okay, a translation of 4 units left and then the y coordinate is going to move us up or down. So since this is a positive number, it is plus 3, I'm increasing y, which means that I would be moving up. So it's a translation of 4 units left and 3 units right. Oh, sorry guys, I don't know. I've never really had an issue like this with my pen before. Not sure what's going so wrong, but hopefully this will continue to work for us. Yeah, so after this, we already have this verbal description. I'm going to go ahead and I'm going to translate each point on triangle KML one by one. So I'm going to start with K, and I'm going to translate that point 4 units left and 3 units up. Wow, I wrote right. Let's fix that. See, I was so distracted by my pen not working correctly. 3 units up. So when I translate K, 4 units left and 3 units up, that point ends up right here. Okay, and I'm going to label that point K prime. Okay. And then once I finish with K, I'm going to move on to another point, and I'm going to translate M, 4 units left and 3 units right, and 3 units up. I don't know why I keep saying right. Which gives me this point here that I will call M prime. And then lastly, I'm going to be translating point L. So as I count 4 units to the left and 3 units up, leaves me with this point here that I will label as L prime. And then in order to have the entire image, I'm just going to connect those dots. And here we can see that I have KML prime. So that is how we translate in a shape. Now we're going to work on translating a line. So looking at the second example, it gives us the verbal description this time. So it tells us to translate the line 3 units down and 1 unit to the left. So I'm going to start by writing my coordinate notation. We should know by now that this always starts with the coordinate xy. And then we're talking about what does xy become when I move from the pre-image to the image. So in that coordinate notation, what is going to happen to my x value? Well, once again, the x value determines whether we're moving right or left. So in this verbal description, it tells us that we're moving 1 unit to the left. So that is what is associated with my x value. And because I'm moving to the left, my x value is decreasing. So that becomes x minus 1. Okay. And then when it comes to the y, that's going to tell us about our translation up or down. So since we've translated 3 units down, my y is decreasing by 3. So I'm going to write in y minus 3. And my coordinate notation becomes xy goes to x minus 1, y minus 3. The next thing on here asks us for the equation of the pre-image. So the pre-image being this line that is already graphed, I'm going to have to write the equation. We've learned a couple different ways to write an equation. We could do point slope form, or we could do slope intercept form. In this case, I can see a clear y-intercept, so it's probably going to be easiest to write this in y-intercept form, which is of the form y equals mx plus b. Okay, I can see here that my y-intercept is 2. So I'm going to go ahead and start by filling that in. I know that at the end of this, I'm adding 2. And then I have to figure out what is my slope. Okay, so I'm going to pick 2 points. I'm going to pick one right here and another, looks like there's one right here. And I'm going to say, how did I have to move to get from that first point to the second point? So to get there, I had to go 1 unit down, and then I had to go 2 units to the right. Okay, so if we talk about this as rise over run, okay, my rise is -1, and my run was 2. So that tells me that my slope was -1/2. And then when I plug that into the formula y equals mx plus b, I'm left with the equation of this line, y is equal to -1/2 x plus 2. Now that I have that, I'm going to go ahead and I am going to translate this line. So I'm actually just going to pick one point. I'm just going to pick that y-intercept because that's the point that's clearest to me. And I'm going to translate that point 3 units down and 1 to the left. So as I move 3 units down and 1 to the left, my y-intercept is now at the coordinate -1, -1. Since this is a straight line, I only have to plot that one point, and then I can use the slope, right? I'm translating, so I'm not changing the slope. I'm just shifting where the line is. So when I translate this line, I've translated that one point, and from here, I'm going to use slope to figure out all the other points. So I know my slope is -1/2, so I'm going to follow that and just use that to give me all of these other points that I can plot, okay? And as I do that, I see where the line is going to be, and I'm going to go ahead and connect them all. And that is now my translated line. That gives me my image. When it comes to writing the equation of this image now, again, there are 2 forms we can do it in. I'm going to show us right now in slope-intercept form. Okay, the intercept is not a whole number here, but that is okay. I can tell that the y-intercept is -1/2 because I know that that line crosses right in the middle of -1 and -2 because of that slope. So y is going to have the same slope, so it's equal to -1/2 x and then minus 1.5. And if I did want to write this in another form, because I can't see the y-intercept as clearly, right, I could also write this as y and then plus 1 because the y-coordinate is -1. And then I still have the slope of -1/2. And then I do x, and then I have to subtract the x-coordinate. The x-coordinate is also -1. So there we go. And this would be the other way I could write the same equation of the line. These two right here, they're interchangeable. They are both equal to each other. Okay, so now that we're done with that, we're going to move on to a review of reflections. So once again, we're going to start with a triangle, just looking at the shape, and then we'll move on to the line. So this first question says to reflect triangle KML over the x-axis. So when I do this, I can either start by writing out the coordinate notation, or I can start by drawing the reflection. For me, instead of memorizing sometimes the coordinate notation, I like to look at the numbers first. And when you're looking at the actual image, sometimes it can be a little easier. So I'm going to go ahead and draw the reflection first. So again, I have the x-axis, and that is this line here. Right? Oh, that was much thicker than I wanted. Okay, but I'm basically going to be reflecting over that line. I cannot get that to go away, so that's just going to stay there. But that was not my intent. Okay. So when I go ahead and I do this, I'm going to go ahead and reflect each of the points individually. So basically, I'm just counting how many units away from the x-axis each point is. So I'm going to start with M. And M is 1 point above the x-axis, so I know the reflection is just going to be 1 point below the x-axis. Okay, and then that gives me M prime. Then I'm going to do the same with K. K is 5 above the x-axis, so I know that the reflection is going to be 5 below the x-axis. Okay, and then lastly, same thing with L. When I come over to where point L is 1 above the x-axis, so then I'm going to move it to 1 below the x-axis. Again, I apologize for those points. My pen is not working great right now, but I'm trying my best. Okay, and then I'm going to go ahead and connect those. And while I'm at it, I need to make sure I label my image as KML prime. Okay. Now I'm going to go ahead and look at the coordinate notation. So again, we're starting with a point that would have been on our pre-image, and now I have to figure out what is changing in the coordinate of the image. So if I look, I've reflected over the x-axis. You can tell that this shape has not moved right or left at all, right? So the x value has not changed. So I'm just going to write in an x. The x has stayed the same. What has changed is that y. You can see that when this was reflected, the image is below the x-axis, whereas the pre-image was above. So if you look at the y value of each of these points, right, K, right, we see this y value of 5. At K prime, you can see the y value of -5. And you see this with M and L too. Their y value is 1, where M and L prime, it's -1. Okay, so for each of those, because we have reflected over the x-axis, my y value has actually become negative. It's become the opposite. So my coordinate notation is that xy becomes x negative y. Next, we have this other question. This question says the same thing. That's not what it's supposed to say. That's my bad. I'm going to fix this real quick. But this should say to reflect triangle KML over the, well, I was going to say y-axis, but let's do it over the line y equals x. We'll sort of like step it up a little bit. Okay, so if I'm reflecting over this line y equals x, first things first, I'm going to draw in that line. We should all know what it looks like at this point. Okay, it is a line with a slope of 1 that goes through the origin. Okay. And when I'm reflecting across this line, again, I am just going to start by drawing the reflection, and then I'm going to go ahead and give the coordinate notation. So since the point L is already on this line, that same exact point is actually also going to be L prime. So I'm just going to sort of darken that in and label that as L prime. For M and K, though, I'm going to actually have to reflect it. So there's a couple different ways that you can go about doing this. So the way that I like to do it is that I just take the point K, and then I'm going to see how far do I have to move to the right to get to this line of reflection. So I'm just going to draw in like an arrow. See, how many units does it take me to get to that line of reflection? And in order to do that, K had to go 7 units. So now, because I had to count 7 units over to find where K is reflected over this line, I can go 7 units down. So if I draw this to 7 units below, that will actually find where the point on my image is. So that is where I have K prime. And then I'm going to do the same exact thing with M. So M, it appears, has to go down 4 units to get to this line of reflection. So I'm going to go right 4 units to find where the image should be. And then I'll just plot a point right there. Okay. So from that point, I'm going to go ahead and connect the dots. I will label M prime. And we now have this reflection of KLM. Before we do the coordinate notation, I'm going to erase some of, I was going to try to erase some of these lines. I'm not really sure what's happening here. Okay, using a different program than I usually do for these things. So maybe I should go back to the other one. Anyways, so sorry it looks a little bit busy right now, but we had our pre-image and we had our image, and now I have to figure out how did I have to change the coordinates to get from the pre-image to the image. So again, coordinate notation, we always start by just listing the point x, y. And then we have to figure out what happened to the x values and what happened to the y values. So I'm going to look at point K just for an example. When I started with K, my coordinate was -2, 5. Okay, and when I had K prime, oh man, this pen is really not working well today. But K prime was at 5, -2. As you can see by those 2 points, we have the x and the y value essentially swapped, right? Instead of -2 and then 5, it's 5 and then -2. So if my x and y swapped, then my coordinate notation is just going to be y, x. Okay, so let's go ahead and move on to reflections of lines. And hopefully my pen will start working better, because that's really starting to get annoying and probably confusing to y'all, so I'm sorry about that. Anyways, though, our next instructions say to reflect the given line over the x-axis. So this is the same line we were looking at up above when we did translations, but now we're going to go ahead and reflect it. So the equation of the pre-image, since it's the same line, is actually going to be the same thing. So I'm going to do this pretty quickly. But again, we have this form y equals mx plus b. So I'm going to take the slope of -1/2 times x and then plus 2. I already have that equation. We already did that in this video. Okay, but now I'm going to go ahead and reflect this line. And again, I'm going to do that before I do the coordinate notation. But it asked me to reflect the line over the x-axis. So I'm going to darken in the x-axis to remind us that that is the line I'm reflecting over. And what I'm going to do is I'm just going to take 2 points on this original line. And these are 2 points I had pointed out in the original problem. I have 0, 2, and I have 2, 1. And then I'm just going to go ahead and I'm going to reflect each of these points. And then when I do that, right, 0, 2 is going to become 0, negative 2. It's going to be just as far on the opposite side of the x-axis. And my other point, 2, 1, is going to become 2, negative 1, right? Again, just reflecting it over the x-axis. And then from there, I can use the slope to find all the other points that are going to be on this line. So there's one, there's one, there's one. Okay, and then I'm going to go ahead and connect them all. So there is my image. And then the last thing I have to do is to find the equation of the image, which again, we can just do in slope-intercept form, will probably be the easiest one in this case. Y equals mx plus b. So I'm going to look at the slope. Okay, the slope, once I reflect the line, may have changed. So I'm going to have to calculate that again, and I'm just going to look between these first 2 points on the left and see I have to go 1 up and 2 to the right in order to get to the next point. So I'm rising 1, and when we do rise over run, I rise 1, I move over 2, it gives me 1/2. So I have 1/2 x, and then my y-intercept in this case is negative 2, so I'm going to say 1/2 x minus 2. That is the equation of my reflected line. Okay. And now we're going to do one last review problem. So at this point we have some practice, but again, this is the same exact line, but now my instructions say to reflect it over the y-axis. So the equation of the pre-image, again, that's going to be the same. Y equals negative 1/2 x plus 2. But I'm going to look at the equation of the image before, sorry, I got distracted. I'm going to reflect the image before I do the coordinate notation. So now I'm reflecting it over the y-axis. So I'm going to darken in that y-axis to remind us this is what I'm reflecting over. And then again, I just need to take a couple points. So I'm going to pick this point here, 2, 1. And then I think I'm going to pick this point here, 4, 0. Doesn't really matter what 2 points. Just got to pick a couple. So at this point, I'm going to go ahead and I'm going to reflect each of those points over the y-axis. We should be pretty good at this by now. So since 2, 1 is 2 to the right of the y-axis, I'm going to put the point 2 to the left of the axis when I reflect it. And then I'm also going to be reflecting the other point, 4, 0, over the y-axis. So that is going to become negative 4, 0. And then once again, from this point, I can just sort of use this slope. You can see I have to go up 1 and over 2, right, to get to the next point. So I'm going to keep doing that, up 1 over 2, up 1 over 2, up 1 over 2, to give me other points that I connect to draw my image. And when I go to find the equation of the image, again, in y equals mx plus b, slope-intercept form, I already sort of found my slope. I said I had to rise 1 and go over 2. So it gives me a slope of 1/2. And then this time, my y-intercept is actually the same. It is still positive 2. Oh, that was supposed to be a 2, not a b. Honestly, the eraser is not working at all, so I apologize. I'm just going to scribble that out and start again to write in 2. And y equals 1/2 x plus 2. Okay. Awesome. Looks good. So hopefully that was helpful and kind of went back over some things again. Again, we'd already learned those, but that was some extra practice. If you have any questions, please go back, look in your notes, check, ask up here. And if you still can't figure it out, go ahead and make sure to ask one of your teachers.